All right, you guys, today we are starting section 9.3, which covers solving quadratics using our knowledge of square roots. So this is a different strategy that you might use, and different to yesterday, we're going to be focusing on using this when the equation is written in some number x squared plus a constant is equal to 0. So you'll notice that there's no x term that's involved in that equation, which makes it a little bit different than what we were solving yesterday. So anytime you have the number squared plus a constant is equal to 0, you'll rewrite it so that you get it to be x squared equals some number. Now, a couple of key points that I want you guys to see. When that number is greater than 0, there will always be two real solutions, which will be a positive and negative square root of that number. If c is equal to 0, there's only going to be one real solution because the square root of 0 is 0, so that would be the solution. And if c is less than 0, so if it is a negative number, there is no real solution because you can't take the square root of a negative number. Anytime you multiply a number by itself, it's going to give you a positive number, whether that's a positive times a positive or a negative times a negative. So if we're taking the square root of a negative number, there is no solution. So let's start by looking at our first problem in example 1. It tells me to solve 3x squared minus 27 equals 0 using square roots. Your first step is always going to be to get it in that x squared equals some number. So notice in my first step, I have added 27 to both sides of the equal sign. So now I have 3x squared equals 27. From there, my goal is still to get x squared by itself. I want to isolate that, so I divided both sides of the equal sign by 3, and that left me with x squared is equal to 9. Now, once I get to x squared is equal to 9, in order to get x by itself, I'm going to take the square root of both sides. So the square root of x squared is x, and the square root of 9 can be positive or negative 3. So notice that I have two solutions here. And since when it was in the form of x squared equals 9, since 9 was positive, since it was bigger than 0, I knew that there would be two solutions, and the solutions are positive and negative 3. In this next example, I am solving x squared minus 10 equals negative 10 using square roots. So my first step is to add 10 to both sides so that I am isolating or getting x squared all by itself. I'm left with x squared equals 0, so this is my clue that there's only going to be one solution since it is equal to 0. To solve and figure out what x equals, if I take the square root of x squared, I am left with x. If I take the square root of 0, that gives me 0, so there is only one solution, and that solution is x is equal to 0. In my last example, letter C, I'm asked to solve negative 5x squared plus 11 equals 16 using square roots. So my first step was to subtract 11 from both sides. I was left with negative 5x squared equals 5. I still want to isolate and get x squared by itself, so I'm going to divide both sides by negative 5. I am left with x squared is equal to negative 1. Now right away, since x squared is equal to a number that is less than 0, that was one of the rules that we reviewed at the beginning, and I should know right away that there is going to be no solution. So again, the reason that there is no solution to this is that there is no real number that I can multiply or multiply by itself, and have it equal negative 1. A positive times a positive will give me a positive, and a negative times a negative will give me a positive, so it is impossible for me to square a number and get negative 1. For that reason, there is no real solution. All right, here are your first 3 monitoring progress problems. You can go ahead and click pause and give these 3 problems a try on your own. All right, so in number 1, you can see that my first step was to divide both sides by negative 3. And when I did that, I was left with x squared equals 25. And then my final step was to take the square root of both sides. Again, since 25 is a positive number, I know that there's going to be two solutions. So x could either be positive 5 or negative 5. In example 2, my first step was to subtract 12 from both sides so that I could get x squared by itself. That left me with x squared is equal to negative 2. Since negative 2 is less than 0 and it is a negative number, there is no real solution. And then in my third example, my first step was to add 15 to both sides, which left me with 4x squared is equal to 0. Now, my next step was to divide by 4 because I wanted to get x squared by itself, and I was left with x squared is equal to 0. And again, I mean, I didn't have to follow through with all of the steps. Right as soon as I see x squared is equal to 0, I will know that there's only going to be one solution, and that solution will be x is equal to 0. The only way you can square a number and let it be equal to 0 is if you're multiplying 0 times 0.